Okay, go ahead, start. You can move.
Sure. All right. Hello, all my dear friends, everybody, respected faculty and senior members here, and all my dear friends. We would like to present you today the thing which we had been working for this semester, our practicum project, and it was really wonderful to work with our team. So I would like to go deep into the details of it. So what was our practicum project? Can you use? All right. Yes. So this was the one thing which we had been working, hybrid cloud computing for privacy-preserved mobile sensing. Now this is a concept of hybrid cloud computing, and this particular paper was written, researched, and worked on by Mr. Joy Sang, who is with us right now, and he's also our practicum advisor. I would like to specially mention our faculty advisor and instructors, Wendy Fawn and Ed Katz, who also helped throughout our journey. Yeah, here it is. All right. So this is our client team, Mr. Jian, Pang, and Ming. So they have guided us throughout the course of the time to what has to be done in our project. Next. All right, and this is our team, INI team, which worked on this practicum. Here it is, Locke, Jingi, Kapil, and myself, Apurva. Just wait. All right, so going deep into it, let's make it, let me just go through the agenda for today, basically. So I am going to introduce the concept of what we had been working, and I will build up the platform. Over it, the technical details would be described by Jingi and Kapil. And after that, Locke is going to demo our app, what we actually did. All right? So we all use different kind of apps, different kind of devices, and those devices are basically generating lots and lots of data. And those data are actually going to a different places called the cloud. Now that is called cloud computing altogether. And this solution, this is like hybrid cloud. So what is hybrid cloud? Every user is basically concerned about where his data is going to be stored. So he wants that his private data, where he goes, where he spends his evenings, where is his offices, all such kind of details remains only to himself. And only if he likes to do transfer those kind of data, he could do that. So this was the overall concept. And so just to introduce the concept, I will draw an analogy. So let's assume that we are a general user. A user like him. He's a minion, and he's saying hi to everyone. All right, and this user actually uses different kind of devices to generate the data. So this data, So this data, I'm just making the analogy as banana as the data. Why? Because there is no physical representation of the data. So banana is data here, and our banana should remain with us. But in the picture, you can see that there are people who are actually looking towards your data. So who are those people? We will just try to understand that in deeper details. Next. All right, so we all, means there are people fighting for the data. This banana can be used by other people. So other people for generating some results, and with those results they are going to target it. They are going to give you targeted advertising, such things. All right. So, but willingly or unwillingly, we are actually sharing our data with other people. So these monsters or these people actually are the data consumer. The term which is called for them is called data consumers. Why data consumer need the data? Just to have the targeted advertising and many such things, like they want to give you customized details about what a user is actually doing. All right? Any questions till now? Pretty clear, right? Yeah, so we are going to have a solution where the data will remain with the user itself. Alright, so diving deep into the technical details of it, we will start where actually we started our practicum. Where were we? How much part of the practicum was already completed when we started? Yeah, please. So yes, this is the mobile sensing flow diagram which we have. The raw data which was collected by the user through different sources, basically mobile in our case, that was going to MobiSense storage. This was a third-party server where all the data was collected in CSV format. These servers were then processing the data and then generating few files which were the results of it, and they were again stored in the cloud, which was live logger servers. In this complete flow, the user has very minimal means proximity over the data. He has no control over the data. All right. So just yeah. So in movie sensing, what kind of data is generally accepted or generally taken? So these are the kind of data which is actually generated or which is collected from the mobile. It could be the proximity, it could be the camera, the different kind of images, the GPS location of yours, compass, gyroscope, accelerometer, all such details are actually collected in the mobile sensing. But our MobiSense app, it was collecting such details, the locations, and this was actually the MobiSense app. These are the screen grabs of the MobiSense app. So this was the Android app which was already developed, and we had this data collected. Okay. Yeah. So what was the concern in the overall thing? So as I said it, the concern was that user has very little control over the data, and we came up with a solution, or the complete team came up with a solution so that the data remains only with the user. Yeah, please. So this was the problem with this mobile app right now, the privacy concerns. So solution was the hybrid cloud. Okay. Yeah. So this is the main diagram of our workflow. Here, if you see the bigger rectangle over here, this rectangle shows that the user has full control of the data in this proximity. So whatever raw data is collected, it is stored in a private cloud, which is again set up in his own machine. In that machine, he has something like widget management system. Widget management system is responsible for dealing with everything. I mean, it processes the data, it collects the data from their raw data, it processes the data, and then if required, it displays it to the user, and if user wants it, user can actually move the data or move the collected or processed information to the data consumers. All right? And just to have this flow completed, we have a widget store. Widget store is basically a place from where you can have the scripts or the widgets. Widgets process the data. So the processing of the data has to be done by the widgets, and this execution of complete storage is done by widget store. Widget store is a third-party place, a trusted place from where you can download the widgets. It will make sure that the widgets does what it has to do, and widget will collect the raw information, process it, and then it will be moved to the data consumer. So this is the overall flow of diagram. Now I will hand it over to Jingi, and she will dive more into the details of technicals. Thank you.
Okay, thanks. So this is the goals of our project. We need to implement the whole pipeline mentioned in the previous slide, so that the MobiSense user can upload raw data to the personal cloud, and user can download widgets from online widget store. Then the widgets can be run on the personal cloud and process on the raw data. Then the widgets can produce analytical data. So Our project consists of three major parts. The first one is MobiSense app. It is an Android app. It is actually an existing app. We made some modification to this app. We modified the push data feature, and we also add two more features, which are register WMS and register widget store. So previously, the data was pushed to the Live Logger, which is a public cloud, and right now the data was pushed to the widget, the virtual machine, which is on the personal cloud. And the register WMS and register widget store is for the user to create new account on the widget store and the widget management system. So the next part is the widget management system, which is the WMS. So it is running on the virtual machine, and it is implemented using Ruby on Rails and MongoDB. So the reason we choose MongoDB is because the raw data and the analytical data has no schema, and the raw data is write once and read multiple times. So that's why we choose MongoDB. So as you can see on the WMS, there's some widgets that are installed and downloaded from the widget store. So the widget will process on the raw data, collected from the MobiSense, and then it will produce analytical data. So the third part is the widget store. It is implemented using Ruby on Rails and Redis. It is an online store, and every user can access it. The user can browse all the widgets that are available and choose the widget to install. Okay, so this is the whole workflow. Start from the first step. The user needs to install the MobiSense app to their smartphone first, and then the user needs to use MobiSense to register themselves to the widget store so that they can create a new account on the widget store. Then they can download the virtual machine to their personal PC or other devices, and then the WMS can be run on the virtual machine. And then the MobiSense can register the user to the WMS. It is similar to the first step. So a new user account can be created on the widget management system, so that user can log in to manage the widgets. And the next step is the MobiSense can push the raw data to the WMS. And in order to process these raw data, the user needs to go to the widget store to choose the widgets to download and install to the WMS. And then the widgets will be installed on WMS, and these widgets will process raw data and produce analytical data. So as you can see, the MobiSense is a mobile app, and the widget management system. The widget management system is on the personal cloud, and the widget store is a public server. So next. The widget store, here is a screenshot of the widget store. It displays all the widgets, and user can install the widget by just click the button. We will have demo of the widget store later on. So the widget store actually has some limitations right now. The user needs to manually register themselves to the widget store by inputting the IP address of the widget store so that they can create a new account on the store. And our future work is to do this automatically so that users don't need to manually input the IP address of the widget store. So a widget basically process all the raw data and then produce analytical data. In order to make use of the Ruby on Rails framework, we implement the widget as a Ruby gem. Right now, the gems are hosted on the gem server. It is very convenient to install these gems by just using one command, gem install and gem name. So next I will hand over to Kapil to talk about the widget management system.
Yeah, so hi everyone. I'll be talking on widget management system, which we also call as WMS. So what is WMS doing? It's basically receiving the raw data from the MobiSense app, which is already installed in the user's smartphone. So when it clicks on the push data feature in the MobiSense app, the data is being pushed on the user's WMS, and the user can manage widgets with the help of WMS, like subscribe to a widget store, or install a widget, or running a widget, display analytics. So when a user runs a widget, some analytics are being created. So they are being displayed on the WMS. And for storing the raw data from the user's end, we are using MongoDB. And we decided to use MongoDB because there were many reasons. So first of all, the raw data coming from the user was having different forms. So we didn't want to like have an overload of relational database or something. So the raw data had varied formats. And second was no schema needed. We wanted to write once and read the data multiple times. And indexing feature is also supported, and since our app was all Ruby on Rails based, so MongoDB has a support for Ruby. So that's a basic WMS design. For example, we are having two widgets, widget 1, widget 2, which is interacting with the core widget runner. Core widget runner is basically loading all the widgets and running the widgets. And so as you can see, we also have an API layer. So what API layer is doing is basically it's having an abstraction layer between the backend database and the widget. So we wanted to prevent the access of backend database from the widget directly. So that's why we have an API abstraction layer. So and we are fetching the backend database with the help of a widget ID, so that so basically that's our basic WMS design. Yeah. So although we have some limitations on the WMS, like user needs to manually register on the WMS. Ideally, it should be automatically registered on the WMS. Secondly, for installing the virtual box and all the configuration, right now we are doing it from the command line. Ideally, it should be automated. And third, whenever we install a new widget, our WMS has to be restarted. And for running the widgets, the user right now needs to click on the run widget button, but ideally it should be having a scheduler to run all the widgets automatically. So that will be counted in our future work.
So how to produce install widget? Does it need to run the command line, or there is a button?
No, it's so whenever the user clicks on the run install widget on the widget store, it automatically gets synced with the WMS, and on the WMS he needs to click on the button called run the widgets,
Nice.
and he can select a specific widget also. Yeah, next slide. So I would now call Log for the demo.
Before the demo, I still don't see why this cannot be run automatically. Downloading a widget, has it run, and also why does the WMS has to be restarted?
So
the whole setup process should be more automatic, right?
Yes, we face some technical limitation right now as we implement our widgets as a Ruby gem. So every time it's install a new gem, it's require the system. This is the Ruby things. It requires the system to restart itself so that it can recognize the new library, the new gem that we just added. Yes.
So what about the command line? Is it possible just to download a gem and double click on it and it will install automatically rather than using command line?
That we have it right now. We provide command line so that once we click install in the widget store, it will call back to the WMS and push the command line to the WMS, so that the BMS can install the gem automatically, and it will restart it automatically.
I see.
Yes. So for the demo, we're gonna show you a video that we have. Okay, let's repeat. Let me repeat you about the whole diagram. So right now we have three components so far. So we have MobiSense, which is application, Android applications, which is running on your devices. And we have the BMS, which is management system, which is run on your virtual machine. Basically, it's your private cloud. And you have a widget store, which is run in the cloud that you can access publicly. So the first step here is that the user has to install MobiSense on your Android phone, and then you have to register the user with the widget store. So this is the step, the flow. So first thing, you have to register MobiSense to widget store. So we have a capture screen on Android app right now. So we can see that we have MobiSense icon here. If you click it, it's going to show you the MobiSense app. So right now we add two components here. We add register widget store, and we add registers to the BMS. The reason is that we have to create a user manually so far, so that the system can recognize you, your device. So if we click register widget store, it's ask you for the IP address of the widget store. And if you click register, it will send the request, and you get the user ID and password back, so that you can use them to log in into your widget store. Okay, so the next step right now, so we're gonna go to our widget store. So, and we can use the username and password from the MobiSense app to log in. So basically, widget store is a web application. You can open the browser and go take a look inside it. We have the list of widgets so far. We have as example 2. So we can see the name of those widgets, and we have the version controls as well, and the timestamp that we created. So right now we haven't logged in yet, so we're gonna use our username and password to log in. So if we click on login button here, it will pop up to sign in, and you will be asked to input the device ID as an email address from which you can get from MobiSense. Okay, we inputting it now, and we can also put the password. Okay, if we sign in, we can see that we have green buttons here, so that we can click to install the widget from widget store to your WMS. But right now we haven't have any WMS running yet, so it's gonna be next step that we're gonna go to create our WMS and run it. So how can we do that? To install the WMS on VM, we provide a script. So basically, the user has to download the script and execute it in his local machines. So basically, the script is Ruby script, So what basically it does is to get the VM, download the VM, and make every and create every configuration for you, so that you can easily have the virtual machines and the WMS system running inside the the VM image itself. So technically, we use VirtualBox as our virtual machine application. Right now, it's installing VirtualBox and then download the code, the WMS code, and it will be the code will be running pretty soon. So as we see here, this is one of our limitations. So we has to in the future world, we're supposed to provide GUIs so that the user can easily click and download and set it the thing out. But so far, we have only the command line.
And how large is the whole package for user to download?
For the VM itself, it's about 600 megabyte.
Yes. Including the VirtualBox itself?
That is 200 MB.
Yes.
And you're assuming user already...
Joy, can you press the button?
Sure. So you also do you also assume that user already installed a VirtualBox?
No.
No.
So the package has both VirtualBox and the VM
That's true.
image?
Yes.
Okay.
So we try to reduce
So in total, the package would be 800 megabytes?
Yeah.
something around that. Yes. Okay. So we also use Vagrant, which is a platform so that we can easily manage our VM. So right now, so far, if it can run successfully, it will show the VirtualBox with the VM running, so that you can have your private cloud running. So so far, we can use username and password to log in. Okay. So so let me capture the flow again. Just 1 second. This showing that you can secure to your machine. Okay. All right. So the next step. Okay. Okay. So the next step is, once you have WMS running, you have to register your mobile phone, so that the WMS system that you have just created can recognize the user. So what we have to do is, okay, so let's back up a little bit. So after we running, let's assume that we have the WMS running. So this showing that you can use web browser to access your WMS. Okay, but one of our limitations here is that we have to know the IP address of the VM, the WMS, so that we can get into it. So, okay, so back to register MobiSense to the WMS. So what you have to do is open your MobiSense app again, and we have a button at the end saying that you want to register yourself with the WMS. Again, you have to input the IP address of the WMS so that it will create the account on the WMS. After that, now you can log into your WMS, which is running on your private cloud. The WMS itself, again, is a web application. So we can use browser to go inside it. We can log in by using your ID and password that you got from MobiSense app too. Okay, so right now the device ID is used because we assume that it's going to be unique across the mobile devices. Okay, so that's why we have all the digits pattern here. Okay.
So have you guys thought about using Facebook or Google to log in? That will be much easier for all three places, right? On the client, on the widget store, and also on your private cloud.
Yeah, that's what one of another improvement as well, if we can do that. But right now we assume that we use device ID one account created at the BMS as one user. So if we have a user, a Facebook user, that means we have many
If you have multiple devices.
multiple devices that related to the Facebook account. But it's possible. I think that's would be pretty good, pretty convenient.
Right.
Yes. And accessing Facebook APIs, it's not it's pretty convenient too.
Right.
Yeah. Okay. Okay. Right now we have our WMS system running. As we see here, we have many tabs inside it. We have widget. So far, we haven't downloaded any widget yet, so it's going to be blank. Also, we have analytics result, and that I'm going to explain later. We have storage, and we have events. So storage is a file that get uploaded by MobiSense app, and the events means the result of the passing of those raw data file. So the next step is we're gonna push the data from MobiSense to our WMS. So what we have to do is pretty easy. We have a push data here. If you click on it, it's gonna push data into our WMS. Okay, we're back to the WMS again. So if you click storage, it's going to see the list of the file that got uploaded just now. So you can see the basic information like the name of the file, the device ID, the size as well, and the status. Right now, the status is uploaded, means you uploaded successfully, and you have you can download it as well if you like to, and the other button saying that, okay, I'm gonna explain that later, but okay, as you see here, as more files is coming from MobiSense, as well, you can see the basic information like size, the type, which is used internally by MobiSense. You can also delete it as well. Okay, so so far we have the raw data that's get uploaded from MobiSense to the WMS. So what's the next step? So the next step is we're gonna pass those data and install in our database. So this process we transform those stories into the events. So it can be done pretty easily right now. So as you can see that we have a little button saying that you want to process the data, and it will convert the file. And as you see here, that's number of lines. If it's done passing successfully, the number of lines shown here, the number of record that you have created, and the status show, okay, it's finished already. So you can later on, after this, delete this file after it's done passed. Okay, so we can see if you click on the event tabs here, you can see the events that it's created. So you can see the basic information like the type. This is the battery record. So you can see here like ID, type, timestamps, the level of battery. So, so right now, so far we have only battery record. We're gonna look for another record so that you can see the different between the events. So, okay, it's gonna wait a little bit. Okay. So right now, new files coming. If we,
So you're doing this in real time?
yep, I'm sorry.
So you're doing this demo in real time? Now you're uploading files?
You mean the reload, right?
Yeah, because I see
Right now, user has to click refresh. I mean, you have to click the storage tab.
Timestamp?
No, I mean, I see the list keeps changing. So
Yes.
I'm just wondering, like, if you
While
guys are-
recording the video, maybe it was the.
Okay. Oh, it's
Okay.
I'm sorry.
It's unreal.
Yeah. Okay. Again, if you go into this file and if you click it, okay, it's gonna process the log. Okay, it's done. You can see here the status has changed to uploaded to finish. So, so if you go to the events tab, you can see now there's a different type of information here. The type, location type of record has just added. So if we click inside it, we can see that the basic information of the location record, such as latitude, longitude, hash speed, or altitudes, those kind of attributes. Okay, so far, we have storage, we have the events, and what we're going to do next is we're going to convert those events into analytics so that we can make use of it, and also we can sell it to the market as well. So how to do that? So what we have to do is we have to install and run the widget. So we can do that by going to the widget store and again log in to your account. Okay. Here, again, username and password. Okay. If you click on the install button, okay, so it's gonna, as I say, it's gonna call back to your WMS and install it from the widget store. Okay, if we go to our WMS, we go to the widget store. So it's not coming yet. The reason is that we have to restart the server, so it's gonna take some time on that, few seconds, and here's go. So as you can see here that you have the list of widgets. So as the example, we have only one widget here. So what basically it does is it will calculate the time spent on the two coordinates. Like if your Mobicen record the location at one point, and another point, it will calculate the time that you spend on between the 2 points. So as you can see here, there is no analytics coming so far. Okay. So next, we're gonna run this widget. So what we have to do is click Run Widgets button. So it will take a few minutes to digest the event and then convert it into analytics result. So I'm going to click Run Widget. Okay. Also, we have to be patient. Again.
We just go fast forward.
A little bit. Just wait for a few seconds. It's coming. Only 1 minute left. Okay. Okay.
And this is running on your laptop?
Yes.
Actual
this-
virtual box.
Yes. So okay. Things okay. If you see in the logs file, see here we turn on debugging and we see the list of the new record that's going to be stored in analytics module. So right now we have so far widgets installed and we can run the WMS to produce widget to produce analytics. So the last step is to browse the widget store. If the widgets run successfully, you can see this result. So to see the widget analytic results, you can go either with this widget, and as you can see here, the list of analytics that has been produced. Also, we have basic information like timestamp, we have relationship like what widget ID. If you go inside it, we can see the timestamp device D, and this is another record that we calculate, like the source, which is the starting point, and the destination, which is the end point, and we calculate the time spent in millisecond. So it means that this guy spent 1 second to move from one point to another point. So all of these are analytics result. Okay, so I think that's pretty much for the demo. The flow it's quite complete now, but it still needs some manual step to do that. Okay. So next we're gonna go back to the slides. Kabir gonna talk about challenges.
Yeah, so I would like to reiterate the pipeline which we implemented. So the user, from the user device, the raw sensor data is being pushed to the user's personal cloud, which is right now the VM. The widget management system is basically storing the raw data, running the widgets, and producing analytics, which the user can control and which can be exported to the data consumers. So that's the whole pipeline which we implemented. Next slide. So in our practicum project, the challenges which we incurred can be classified broadly in 3 categories. Like first of all, the widget installation. So with the use of Rails framework, we implemented a widget as a gem, which could be downloaded and installed on WMS. And secondly, the WMS and the widget store needs to be in sync, so that to know that which widget is being installed and running. So that was for the widget installation. Secondly was the sandboxing of widgets. So we didn't want the widgets to directly access the backend database. So we provided an API layer for the abstraction. And thirdly, the virtual machine. So there were a lot of configurations for the virtual machine. So we were preparing user machine to run on the private cloud. So those are the challenges. And the contributions, like we implemented the whole workflow of the hybrid cloud approach. Secondly, the user can have complete control over the raw data as well as the analytic data produced by the widgets. And thirdly, so that can be the analytic data can be chosen by the user to export to the data consumers. So that can be the future work, which I would reiterate. The user account on the widget store can be made automatically as well as on the WMS. The widget VM part can be done with the help of a GUI, and the WMS has not to be restarted after installing of each widget, and running the widgets automatically can be implemented with the help of a scheduler. So probably that can be a future work. So these are our references. So thank you. Any questions?
It's pretty good. One possible improvement is that sometimes the user wants to specify a range, which raw data they want to process by the.
Can you push the button?
Oh, so sometimes the user want to specify a selection or a collection of raw data to be processed. In your current system, you basically, once you run the widget, you will apply the analytics method to all the data. So it will be good that you can have that flexibility for user to choose, instead of at the end of the stage, at the end of the workflow, you select which analytics to expose. So basically, you do the selection in the beginning. So you basically save the power, processing power on your personal cloud. So just another possible improvement area.
Yeah, that's gonna come with the scheduler things.
So how do the user know like, which type of data that?
Can you push the button?
Yeah, I pressed.
Okay.
So how do a user know which type of sensor data that a widget is going to be run over?
Okay,
Is
so
there a way-
right now the user doesn't know about that, but as so this is gonna be another area of improvement. So once you want to install a widget, so there might be something like a permission request, so that if you want to install this widget, is you list the permission, the record type that this widget gonna do, and saying that okay, if you want to install the widgets, do you agree to let this widget access those kind of system? So that's gonna be another improvement area. This can,
And like for right now, we are just having a widget description in which we are mentioning that we are accessing the field of this type, like Wi-Fi access point or location, things like that.
You know, it's a lot of work, especially from the beginning of the semester. I can tell you guys have spent a lot of time getting this done. So first of all, congratulations.
Push
we
the
actually-
button.
Say it again. So congratulations of the good work. So the whole pipeline actually demonstrates this is feasible. I think that's the whole purpose of the practicum. Of course, from the user's perspective, you know, as I said at the beginning of the semester, my hope is that my mother can do this without my help. But at this stage, I think even I have to look up at the menu to do this step by step. So there's lots of room to improve for the next step. Whether your team wants to do it or some other team can build on top of your work to make this really user-friendly. So one small thing, for example, I would rather call WMS as a private cloud or something different, because when you look at the MobiSense app, there's a register to widget store and also register to WMS, right? It took me several seconds to figure out which is which. And also from your laptop, when you open up the browser, both widget store and also your private cloud all have the same web interface. They'll all show up as a web page, right? For some user who has no computer science training and hasn't read our paper yet, or took them several minutes to figure out what's the difference between them and where does the data actually go through. So the whole point of the project is that we want to make sure that users feel comfortable that their data really only resides on their computer. So from user interface design or the user experience, we want to enforce that, right? So that when user look at this web page, when it says it's private cloud, he or she should feel comfortable that they understand this is where the private cloud is running and data only resides there. But you know, again, just for one semester, I think this is a lot of work, and the whole pipeline is smooth. Even there's not one push button, we push many buttons, but yeah, it's a good feasibility study.
thank you very much.
All right, thank you.
Okay.
All right, good work. Okay.
How can I have the